Skill Enhancement Course, SEC. Artificial Intelligence. Course 1. Azure AI Fundamentals, I-900. AI 900 Pathway consists of 5 courses and 2 reading material. Unit 1. Introduction to AI on Azure. Unit 2. Use visual tools to create machine learning models with Azure Machine Learning. Unit 3. Explore computer vision in Microsoft Azure. Unit 4. Explore natural language processing. Unit 5. Explore conversational AI. Unit 6. Tune model hyperparameters. Azure Machine Learning, Reading. Unit 7. Neural network regression. Module reference. Azure Machine Learning, Reading. Unit 1. Introduction to AI on Azure. With AI, we can build solutions that seemed like science fiction a short time ago, enabling incredible advances in healthcare, financial management, environmental protection, and other areas to make a better world for everyone. Learning objectives. In this module, you'll learn about the kinds of solution AI can make possible and considerations for responsible AI practices. Introduction to AI. AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. What is AI? Simply put, AI is the creation of software that imitates human behaviors and capabilities. Key workloads include machine learning. This is often the foundation for an AI system, and is the way we teach a computer model to make prediction and draw conclusions from data. Black circle anomaly detection, the capability to automatically detect errors or unusual activity in a system. Computer vision, the capability of software to interpret the world visually through cameras, video, and images. Natural language processing, the capability for a computer to interpret written or spoken language and respond in kind. Knowledge mining, the capability to extract information from large volumes of often unstructured data to create a searchable knowledge store. Understand machine learning. Machine learning is the foundation for most AI solutions. Let's start by looking at a real-world example of how machine learning can be used to solve a difficult problem. Sustainable farming techniques are essential to maximize food production while protecting a fragile environment. The Yield, an agricultural technology company based in Australia, uses sensors, data and machine learning to help farmers make informed decisions related to weather, soil and plant conditions. How machine learning works. So how do machines learn? The answer is, from data. In today's world, we create huge volumes of data as we go about our everyday lives. From the text messages, emails, and social media posts we send to the photographs and videos we take on our phones, we generate massive amounts of information. More data still is created by millions of sensors in our homes, cars, cities, public transport infrastructure, and factories. Data scientists can use all of that data to train machine learning models that can make predictions and inferences based on the relationships they find in the data. For example, suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflower using a phone app. The following animation shows how machine learning can be used to enable this scenario. 1. 2. Rosa multiflora. Bellis perennis. Tulipa. 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 1. A team of botanists and scientists collect data on wildflower samples. 2. The team labels the samples with the correct species. 3. The labeled data is processed using an algorithm that finds relationships between the features of the samples and the labeled species. 4. The results of the algorithm are encapsulated in a model. 5. When new samples are found by volunteers, the model can identify the correct species label. Machine learning in Microsoft Azure. Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for creating, managing, and publishing machine learning models. Azure Machine Learning provides the following features and capabilities. Feature. Capability. Automated learning. This feature enables non-experts to quickly create an effective machine learning model from data. Azure Machine, a graphical interface enabling no-code development of machine learning. Learning Designer Solutions. And compute cloud-based data storage and compute resources that professional data scientists can use to run data experiment code at scale. Data management. Pipelines. Data scientists, software engineers, and IT operations professionals can define pipelines to orchestrate model training, deployment, and management tasks. Understand anomaly detection. Imagine you're creating a software system to monitor credit card transactions and detect unusual usage patterns that might indicate fraud. Or an application that tracks activity in an automated production line and identifies failures. Or a racing car telemetry system that uses sensors to proactively warn engineers about potential mechanical failures before they happen. These kinds of scenario can be addressed by using anomaly detection, a machine learning-based technique that analyzes data over time and identifies unusual changes. Let's explore how anomaly detection might help in the racing car scenario. 1. Sensors in the car collect telemetry, such as engine revolutions, brake temperature, and so on. 2. An anomaly detection model is trained to understand expected fluctuations in the telemetry measurements over time. 3. If a measurement occurs outside of the normal expected range, the model reports an anomaly that can be used to alert the race engineer to call the driver in for a pit stop to fix the issue before it forces retirement from the race. Anomaly detection in Microsoft Azure. In Microsoft Azure, the Anomaly Detector service provides an application programming interface, API, that developers can use to create anomaly detection solutions. Understand computer vision. Computer vision is an area of AI that deals with visual processing. Let's explore some of the possibilities that computer vision brings. The Seeing AI app is a great example of the power of computer vision. Designed for the blind and low vision community, the Seeing AI app harnesses the power of eye to open up the visual world and describe nearby people, text, and objects. View the following video to learn more about Seeing AI. https://www.microsoft.com/n-us/videoplayers/embed/re4vc2q?mark post.jsims=true. Computer vision models and capabilities. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. The following table describes common computer vision tasks. Task. Description. Image classification. Taxi. Image classification involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. Bus. Object detection. Bus. Car. Cyclist. Cyclist. Object detection machine learning models are trained to classify individual objects within an image and identify their location with a bounding box. For example, a traffic monitoring solution might use object detection to identify the location of different classes of vehicle. Task. Description. Semantic segmentation. Bus car. Cyclist. Semantic segmentation is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, a traffic monitoring solution might overlay traffic images with mask layers to highlight different vehicles using specific colors. Image analysis. A person with a dog on a street. You can create solutions that combine machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scene shown in the image. Task. Description. Face. Detection, analysis, and recognition. Face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classification and facial geometry analysis techniques to recognize individuals based on their facial features. Optical character recognition, OCR. Extrans Dominion Bank. The Toronto Dominion. The Toronto Dominion Bank. Optical character recognition is a technique used to detect and read text in images. You can use OCR to read text in photographs, for example, road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. Computer vision services in Microsoft Azure. Microsoft Azure provides the following cognitive services to help you create computer vision solutions. Service. Capabilities. Computer. You can use this service to analyze images and video and extract descriptions, tags, objects, and text. Vision. Custom Vision use this service to train custom image classification and object detection models using your own images. Face. The Face service enables you to build face detection and facial recognition solutions. Form. Recognizer. Use this service to extract information from scanned forms and invoices. Understand natural language processing completed 100 XP. Black circle 3 minutes. Natural language processing, NLP, is the area of AI that deals with creating software that understands written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, email messages, and other sources. Interpret spoken language and synthesize speech responses. Automatically translate spoken or written phrases between languages. Black circle interpret commands and determine appropriate actions. For example, Starship Commander is a virtual reality (VR) game from Human Interact that takes place in a science fiction world. The game uses natural language processing to enable players to control the narrative and interact with in-game characters and starship systems. Watch the following video to learn more. Natural language processing in Microsoft Azure. In Microsoft Azure, you can use the following cognitive services to build natural language processing solutions. Service. Capabilities. Language. Use this service to access features for understanding and analyzing text, training language models that can understand spoken or text-based commands, and building intelligent applications. Translator. Use this service to translate text between more than 60 languages. Speech. Use this service to recognize and synthesize speech and to translate spoken languages. Azure Bot. This service provides a platform for conversational AI, the capability of a software agent to participate in a conversation. Developers can use the BOR framework to create a bot and manage it with Azure Bot Service, integrating back-end services like language and connecting to channels for web chat, email, Microsoft Teams, and others. Understand knowledge mining. Knowledge mining is the term used to describe solutions that involve extracting information from large volumes of often unstructured data to create a searchable knowledge store. Knowledge mining in Microsoft Azure. One of these knowledge mining solutions is Azure Cognitive Search, a private, enterprise search solution that has tools for building indexes. The indexes can then be used for internal-only use, or to enable searchable content on public-facing Internet assets. Azure Cognitive Search can utilize the built-in AI capabilities of Azure Cognitive Services such as image processing, content extraction, and natural language processing to perform knowledge mining of documents. The product's AI capabilities makes it possible to index previously unsearchable documents and to extract and surface insights from large amounts of data quickly. Challenges and risks with AI. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. The following table shows some of the potential challenges and risks facing an AI application developer. Challenge or risk. Example. Bias can affect results. A loan approval model discriminates by gender due to bias in the data with which it was trained. Errors may cause harm. An autonomous vehicle experiences a system failure and causes a collision. Data could be exposed. A medical diagnostic bot is trained using sensitive patient data, which is stored insecurely. Solutions may not work. A home automation assistant provides no audio output for visually. For everyone. Users must trust complex system. Impaired users. An AI-based financial tool makes investment recommendations. What are they based on? Who's liable for AI-driven? An innocent person is convicted of a crime based on evidence from decisions? Facial recognition. Who's responsible? Understand responsible AI. At Microsoft, AI software development is guided by a set of 6 principles, designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. Fairness. AI systems should treat all people fairly. For example, suppose you create a machine learning model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. This bias could be based on gender, ethnicity, or other factors that result in an unfair advantage or disadvantage to specific groups of applicants. Azure Machine Learning includes the capability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers identify and mitigate bias in the model. Another example is Microsoft's implementation of Responsible AI with the Face service, which retires facial recognition capabilities that can be used to try to infer emotional states and identity attributes. These capabilities, if misused, can subject people to stereotyping, discrimination, or unfair denial of services. For more details about considerations for fairness, watch the following video. Reliability and safety. AI systems should perform reliably and safely. For example, consider an AI-based software system for an autonomous vehicle, or a machine learning model that diagnoses patient symptoms and recommends prescriptions. Unreliability in these kinds of systems can result in substantial risk to human life. AI-based software application development must be subjected to rigorous testing and deployment management processes to ensure that they work as expected before release. For more information about considerations for reliability and safety, watch the following video. Privacy and security. AI systems should be secure and respect privacy. The machine learning models on which AI systems are based rely on large volumes of data, which may contain personal details that must be kept private. Even after the models are trained and the system is in production, privacy and security need to be considered. As the system uses new data to make predictions or take action, both the data and decisions made from the data may be subject to privacy or security concerns. For more details about considerations for privacy and security, watch the following video. Inclusiveness. AI systems should empower everyone and engage people. AI should bring benefits to all parts of society, regardless of physical ability, gender, sexual orientation, ethnicity, or other factors. For more details about considerations for inclusiveness, watch the following video. Transparency. Systems should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitations may be expected. For more details about considerations for transparency, watch the following video. Accountability. People should be accountable for AI systems. Designers and developers of AI-based solutions should work within a framework of governance and organizational principles that ensure the solution meets ethical and legal standards that are clearly defined. For more details about considerations for accountability, watch the following video. The principles of responsible AI can help you understand some of the challenges facing developers as they try to create ethical AI solutions. Knowledge check. 1. You want to create a model to predict sales of ice cream based on historic data that includes daily ice cream sales totals and weather measurements. Which Azure service should you use? Azure Machine Learning, Azure Bot, Black Circle Language. 2. You are designing an AI application that uses images to detect cracks in car windshields and warn drivers when a windshield should be repaired or replaced. What AI workload is described? Computer vision, anomaly detection, natural language processing. 3. A predictive app provides audio output for visually impaired users. Which principle of responsible AI is reflected here? Transparency, inclusiveness, black circle fairness. Summary. Artificial intelligence enables the creation of powerful solutions to many kinds of problems. AI systems can exhibit human characteristics to analyze the world around them, make predictions or inferences, and act on them in ways that we could only imagine a short time ago. With this power comes responsibility. As developers of AI solutions, we must apply principles that ensure that everyone benefits from AI without disadvantaging any individual or section of society.